How are you all? I hope you all are fine and safe. Welcome back to Quantum Mathematics. I am Man Gupta, teaching you mathematics, and today I came back with class 12th mathematics that we are going to revise today. Actually, my boards are upcoming for mathematics, that is why I'm thinking to revise it for myself as well as like record video to help you out if you are in class 12th. So I think, I think we should just dive it in, and we're going to complete each and every chapter thoroughly. And don't worry, I'll explain you each and every stuff that we're going to deal with today, and we will study this in detail. Don't worry. Okay, so now we are going to begin with our first chapter, that is relation and function, right? Okay, so like I will be highlighting the most important things firstly, and I don't want to waste my time explaining you unnecessary stuffs. Okay, so you can, if you have time, then you can read these stuffs like the definition of relation and types of relation. These stuffs out, but it's not necessary for me and for those who are looking for like their boards. So what is necessary is this thing, these three things. Okay, let me explain you it. Okay, let me explain it to you. So first we have reflexive relation. It's a type of relation. Okay, reflexive relation says a number or an element is relating with itself, and if it is, then that relation is called reflexive relation. Okay, like here you can see a comma is a belongs to r for all a belongs to a. So this is called a reflexive relation. Second, symmetric relation. If a comma b belongs to r, then b comma a belongs to all, like b comma a should also belongs to r, and if so, then that relation is called symmetric relation. And here a comma b should belongs to a, right? Next, transitive relation. If a comma b belongs to r and c b comma c is also belonging to r, then a comma c should must belong to r to make that relation transitive. I hope you understand that. Like a comma b and then b comma c, just remove these b's from our final this result, right? I hope you understand that. I just want you to understand the trick. Okay, and then if these three relate, like if a relation in a set is said to be equivalence relation, if reflexive, r is reflexive, symmetric and transitive, it basically means that if a function is reflexive plus symmetric plus transitive, then this comes out to be like we say that this is called equivalence relation. That's it. Like in board exams, 5 mark question says that prove this is equivalence relation, right? So that's what you need to understand. Okay, and now we're moving towards equivalence class. So what's equivalence class? Let r be an equivalence relation on a set A, and let A belongs to like capital A, right? Then we define the equivalence class of A as this big bracket, as B belongs to A, B is related to A, right? And that is this. I hope you understand that, right? Okay, now we're moving towards functions, the second part of this chapter, right? Again, no, don't need to move for unnecessary stuffs. Okay, types of function. So, one function or injective function. Well, to check a function, whether it is one or not, just like if let's say you have a function f of x, then put x, like replace x with f of like x1, and equate it with replacing that x with x2. And if this comes out to be x1 equals x2, then your function is called the like that, then your function is on to one function, sorry, one function, right. Okay, let me just yeah, here if f of x1 equals f of x2, and that implies that x1 equals x2, then our function is 1 1 function, right? And if not, like if x1 is not equal to f2, or f of x1 is not equal to f of x2, then that is called mean even functions. That's it. And please remember that 1 1 function is also known as injective function, because sometimes board just play with like words. And what is into function? Well, from like before into, let's come up to onto function. So let's say that you have a function f of x equated with y, and then solve for x from here, right? Let's say that x is coming out to be some f of y, right? Because you're going to have some, I hope you understand that you just have to solve for x from this equation, right? And then look for whether your function is like valid for the given condition in your question is or not. And if yes, then your function is like onto function, and if not, then your function is into function. You have to check it out. In your, like, you have given in your question, let's say that like in some questions x belongs to r, and neglecting let's say some constant c. So you just have to check that whether in your function y equals, if x minus c comes out in your, like when you solve for, oh sorry, here you have to solve for x, right? So yeah, this is what it comes out, and don't think about the numerator. So if this comes out, then your function is onto, because you have given that this is like this is because when you plug c in this equation, then this is undefined. So that is why you have to just not putting c over there, right, to get a finite result or a valid result. That is why, that's it. And that again, it's called as onto function, and then other name is surjective function. And when you combine onto and 1 1, you get bijective function, a function in which is 1 1 and onto both is called bijective function, right? Okay, and now we are good to go with this chapter. We are done with this, and let's talk about some one marker questions. So number of 1 1 functions from a to a is n factorial. Please remember that. Number of onto functions from a to a is also n factorial. Even number of bijective functions from a to a is n factorial. Okay, total number of relations from set a to b is 2 to the m times n, and m is the number of elements in set a, and n is the number of elements in set b. Total number of relations on the set a, yeah, this is quite like hidden, but maybe boards will ask you some questions on this, I'm not sure. Okay, total number of functions from the set a to b is n to the m. Total number of functions, okay, that was total number of relations. Okay, total number of 1 1 functions from set a to b is n p m. Well, let me just explain it to you. This is written n factorial over n minus m factorial, I think. Yeah, I think it's correct. Okay, that is what, or maybe it's also hidden, so you don't need to care about that. And now composite functions, it's not necessary. Yeah, okay. And now we are moving towards inverse trigonometric functions. We are done with the first chapter. Okay, so this chapter is gonna full of identities or formulas. Okay, so just please be patient, and if you want, please note it down in your notebook. So 1 pi radians equals 180 degree, and this is theta, right? Well, this is some physics type of things, but we are going to, like, I hope these things are clear from you, because these are the stuffs that we studied in class 10th. So I can maybe I can assume that you are good to go with this. Okay, now let's move on to the important parts. Sine 90 minus theta or sine pi by 2 minus theta is cosine theta, and vice versa with the cosine function, right? And all this stuffs, right? you just have to change the function with the respective ones. Like cosine will be changed with sine, and sine will be changed as cosine. Tan will be changed with cotangent, and cotangent will be changed with tangent. Secant will be changed with cosecant, and cosecant will be changed with secant, right? That's it. Now here comes the important part. Cosine of minus theta is cosine theta, but sine of minus theta is minus sine theta. Same for the tangent of minus theta is minus tangent theta. And these are stuffs again class 10th. Okay, again class 10th, class 10th, and class 10th. Okay, and these are some ranges of sine function, cosine function, and tangent function. Okay, so here comes the 11th class stuffs. Sine a plus b is sine a cos b plus cos a sine b. Sine a minus b is sine a cos b minus cos a sine b. Cos a plus b is cos a cos b minus sine a sine b. Cos a minus b is cos a cos b plus sine a sine b. Tangent of a plus b is tangent of a plus tangent of b upon 1 minus tangent of a times tangent of b. And tangent of a minus b is tangent of a minus tangent of b upon 1 plus tangent of a times tangent of b. Okay, I know guys it's quite hard, but I must say that you must have studied these kind of things earlier. But if you haven't, please don't take load, because these are the stuffs of class 11th, but we are going to just have a look on class 12 stuffs here. This is inverse trigonometric functions, but let me just revise all the stuffs, okay, firstly, and then we will move to that. And 2 sine of a times cosine of b equals sine of a plus b plus sine of a minus b. You can prove it down while using these formulas, right? And same for all the stuffs, you can prove them down. Okay, that's it. And if you ask that you have to find the value of like 2 sine something or 2 or cosine something, then you can prove it down, or maybe you can just read it down, right? Okay, sine a plus sine b is 2 sine of a plus b over 2 times cosine of a minus b over 2. Sine of a minus sine of b is 2 times cosine of a plus b over 2 times sine of a minus b over 2. Cosine of a plus cosine of b equals 2 times cosine of a plus b over 2 times cosine of a minus b over 2. And here comes the catch, improper or abnormal. Cosine of a minus cosine of b is minus 2 times of sine of a plus b over 2 times sine of a minus b over 2, right? Okay, please remember this formula, this is quite important. Sine of 2a is 2 sine of a times cosine of a, and then that 2 equals 2 times of tangent of a over 1 plus tangent square a. Cosine of 2a equals cosine square a minus sine square a equals 2 cosine square a minus 1 equals 1 minus 2 sine square a, and that 2 finally equals 1 minus tangent square a upon 1 plus tangent square a. Tangent 2a is 2 tangent a over 1 minus tangent square a. Okay, then sine of 3a is 3 sine a minus 4 sine cube a. Cosine of 3a is 4 cos cosine cube a minus 3 cosine a. And finally tangent 3a is 3 tangent a minus tan cube a upon 1 minus 3 tangent square. That's it. So if you can revise these much formulas, then you are good to go with this chapter. That's it. We don't need to remember all the stuffs. Okay, and now like general solutions. So if sine theta equals 0, then the general solution is theta equals n pi and belongs to z. Okay, if cosine theta equals 0, then theta equals 2n plus 1 times pi over 2, again n belongs to z. If tan theta equals 0, then theta same of sine theta equals 0, that is theta equals n pi, and n belongs to z. If sine theta equals sine alpha, then theta belongs to n pi plus minus 1 to the n times alpha, and n belongs to z. Cosine theta equals cosine of alpha is 2n pi plus minus alpha, n belongs to z. Well, n is belonging to z, so I don't think I should tell you that again and again. And tangent theta equals tangent alpha, then the term for sine is repeated but with only positive, but in sine, no, oh sorry, this is being repeated, but here plus minus, and okay, relax, just forget what I said. Tan theta equals tan alpha equals theta equals n pi plus alpha, that's it. And if these are just happening, then you can just check this out. Again comes the important part, and these are the things that are being used in higher mathematics. Even I have used a lot of times in my video that I've uploaded on my YouTube. Sine of n pi equals 0, cosine of n pi equals negative 1 to the n, and tan of n pi is also 0. Okay, and now we are moving towards the targeted chapter, that is inverse trigonometric function. Okay, so arc sine, well, arc sine is also sine inverse. So maybe if I'm just pronunciating it arc sine, so don't get confused like that. Okay, so arc sine, the domain of this is this, and the range is from negative pi to pi, negative pi over pi to pi over 2 to pi over 2. And same for all the stuffs. I don't need to just tell them, you just have to write them down, or maybe you have to just remember this or claim it. What do I say? And sine inverse of minus x is minus of sine inverse of x. You can check out the domains. Cosine inverse of minus x is pi minus cosine inverse of x, and tangent inverse of minus x is minus tangent inverse of x. That's it. Okay, next, sine inverse of 1 over x equals cosecant inverse of x. Remember that cosine inverse of 1 over x equals secant inverse of x, and tangent inverse, like there are having this is having two different parts. When x greater than 0, then this comes out to be cotangent inverse of x, but when x is less than 0, then this comes out to be minus pi plus cotangent of x. These are very important, please remember that, because I have seen a lot of questions you asked on this thing, and these things are useless. I think they doesn't mean to us anything, or maybe you can just write them down, because again I don't want to waste my time just teaching you unnecessary stuffs. That's why I'm just moving up. And well, you can just check this out, that trigonometry, like in trigonometry, this is going to be helping us a lot, right? Or maybe I'm just going to prove something with the help of this, right? Well, you'll see later in the trigonometry chapter, integral chapter. And now we're moving towards the second chapter, that is matrices. So transpose of a matrix is, let's say that this is a1, a11, a12, a13, a21, a22, a23, a31, a32, and a33. So if let's say that this is A, if I'm talking about A transpose, then A transpose is a11, a12, a13. Look, put take these three stuffs and align them in vertically, and then take these stuffs and align them for vertically in the second column. and take this stuff and align them in the third column. That's it. So that becomes A21, A22, A23, A31, A32, and finally A33. That's it. This is the transpose. Okay. So there are some properties of transpose. A transpose and that 2 transpose comes out to be A. Obviously that's common sense. A plus B transpose comes out to be A transpose plus B transpose. A times B transpose comes out to be B transpose times A transpose. The order matters, please care about that. A constant times a matrix whole transpose comes out to be the constant outside the transpose of the matrix. Okay, a square matrix is called symmetric matrix if this, like, I have to zoom it down, Aij j equals Aj. So this is what a symmetric matrix say, or maybe you can just check this out while looking at this. A transpose equals A. And a square matrix is called skew symmetric matrix if Aij equals negative of Aj, or maybe the transpose is negative of the matrix. That's it. And the rest of the things will be seen in the next chapter, that is determinants. So a square matrix is a singular matrix if a matrix, like if you have given that your matrix or determinant is 0, the determinant of your matrix is 0, then you have to understand that this is singular matrix, right? Okay. And next I think, okay, so minor. Okay, let me just teach you what is minor. Let's say that let's talk about a matrix A11, A22, A12, A21, A22, 2 by 2 matrix, right? So the minor of A11 is A22, right? You just have to cancel along with the row and along with the column of that respective term which you required the minor for, and the rest of the things would be like this. And same for the 3 3. If we talk about the 3 by 3, A11, A12, A13, A21, A31, A22, A32, A33, A23 and A33. So let's say that I'm talking about the minor of A21. So what you have to do is, like, I'm talking about this, right? So the respective row will be cancelled down like this. Don't do this in examination, I'm just explaining to you. And the rest of the things would be moving as they go. So you just have to multiply this thing with this. It means that A12 times A33 minus A13 times A32. That's it. So that is how we calculate the cofactor. And let me tell you that's how we calculate minor of an element. And that's like we use cofactor to evaluate. Let's say that A11, cofactor of A11, or Aij. So cofactor is -1 to the I plus j times the minor of Aij. That's it. Let's talk about M11, like in this case. So the cofactor of A11 is -1 to the 1 plus 1, I plus j, and times the minor of A11. So minor of A11 was A22. So this comes out to be A22. That's it, because this is going to be positive one. But if you talk about an element that like after adding the order of that element comes out to be negative, then you're going to have cofactor negative, right? Like after adding them up, if you're having odd, then the negative 1 to the odd is all obviously odd, so you're going to have your cofactor negative, right, for that case. So this is what this is cofactor actually, right? This is cofactor. I hope you can see that, or we can just like denote it with C. Anyways, okay, adjoint of a matrix. In adjoint, what you have to remember, let me just drink a cup of water, please. Okay, so we were on adjoint, right? So in adjoint, mostly, or you have to just remember this formula. Okay, let's forget this, or let me tell you that. So adjoint of A, let's say that A is A11, A12, A13, and A21, A31, A22, A32, A23, and A33. So adjoint says take the cofactor of respective terms, that is C11, C12, C13, C21, C21, C31, C22, C32, C33, C23, and C33, right? You take the cofactor of respective terms on their places and then take the transpose of that matrix, and that is what the adjoint of a matrix is all about, right? That's it. And there are some properties of adjoint. So A times adjoint of A is the determinant of A times the identity matrix, right? Another important, please remember this. And the adjoint of A transpose is adjoint of A transpose. Like, I hope you understand that. And this is important. This is a previous year asked question. The adjoint of A times B is adjoint of B times adjoint of A. And this is a very important. Again, this is an asked question previous year. Adjoint determinant of adjoint of A equals determinant of A whole to the n minus 1, where n is the order of the matrix. Okay, and then okay, that's good. This is also important. When a square matrix is invertible if there exists a square matrix B of the same order. Well, B is invertible matrix, invertible of A. So that's what, here you can see that. Okay, then we talk about inverse matrix. So most importantly, this is the formula for inverse matrix: adjoint of A over the determinant of A. Or maybe you can remember like these formulas even, because yeah, they are important. That's it, right? And now area of a triangle with, or yeah, area of triangle in given xy plane. So the area comes out to be 1 over 2 times the determinant of x1, x2, x3 as written over there, y1, y2, y3, 1, 1, 1. Yeah, that's it. Okay. Now we are good to go with the next chapter, that is continuity and differentiability. So successfully we have done our algebra part, and now we are heading towards our calculus part, that is the first chapter, the very first chapter, that is the continuity and differentiability. So basically what you have to do in this chapter, like in this first part, the continuity, you have to just like you have to know a lot of things from limits. That is a chapter in 11th standard. But what are important limits? So let me tell you that these all things can be proven by using L'Hopital rule, right? L'Hopital rule is it, what it basically says that limit x tends to a of f of x over g of x, let's say that, right? So what L'Hopital rule says that limit x tends to, it is equal to the limit x tends to a that f dash x over g dash x. You take the derivative of the upper function and the lower function, and you can take the derivative so many times, multiple times, like how much time the function needs to be differentiated, right? It's up to you and your function. So first limit is limit x tends to a of x to the n minus a to the n over x minus a is n times a to the n minus 1, easily be proven by using L'Hopital rule. Next, limit x tends to 0 of sine of x over x equals 1, again proven by L'Hopital rule. If you want, you can prove it down right away. Limit x tends to 0 tangent of x over x equals 1, easy. Limit x tends to 0, or let me tell you one of these. Let's talk about this one. So using L'Hopital rule, I'm taking the derivative of the upper function. So if we take the derivative of the upper function, it comes out to be n x minus x times x to the n minus 1, because a is a constant, so this is going to be 0, and in the denominator I'm going to have this thing, that is x minus a. So x is, like, a is constant, so I'm just going to have the derivative of x, that is 1. It means I'm having limit x tends to a of this function. When you replace x with a n times a to the n minus 1, you're getting the same result. That's it. So this is how it's very easy to like evaluate, right? And same for all the stuffs. Mostly I would say that this is going to be used, this and maybe this one. That's it. Okay, now we are moving towards our chapter. A function f of x is continuous at x equals a if and only if limit x tends to a of f of x equals f of a. That is, the left hand limit should be equal to the right hand limit, and that too equals to the limit at that value, right? Limit x tends to a minus of f of x should be equal to limit x tends to a plus of f of x, and that too equal to the function at that value, at that point. So these are the following functions that are continuous everywhere. So if you ask, please be careful, like constant function, identity function, polynomial function, modulus function, exponential function, and sine and cosine function. So they are constant everywhere. But if we talk about these like four types of functions, then they are continuous in their domains, respectively domains, right? Okay. And if we talk about the derivative, a function is differentiable at x equals a if limit x tends to a of f of x minus f of a over x minus a exists finitely, that is this thing. Limit x h tends to 0 of f of a plus h minus f of a over h, like the left hand, no, the right hand part, and then limit h tends to 0 of f of a minus h minus f of a over minus h. You just have to replace it with minus h on the right hand side. That's it. Okay. And yeah, now we're heading towards some of the basic like derivatives. So the derivative of x to the n is n times x to the n minus 1. The derivative of log x to the base e is 1 over x. The derivative of e to the x is e to the x itself. The derivative of a to the x, where a is a constant, is a to the x times log of a to the base e. The derivative of sine of x is cosine of x, and the derivative of cosine of x is negative sine of x. The derivative of tangent of x is secant square of x. Derivative of cotangent of x is minus cosecant square of x. The derivative of secant of x is secant x times tangent x, and the derivative of cosecant x is minus cosecant x times cotangent x. Okay, and if you want, you can remember these stuffs, or else we are going to just have a look of them in the integral chapter. Okay, so basically what chain rule says here, chain rule is very important in differentiation. Let's talk about, we are having like f of x multiplied with g of x, and if I want to take the derivative of this with respect to x, then it says that take the derivative of the first function, second function as it is, plus the first function as it is times the derivative of the second function. That's it. So this is what it basically says, right? And what about the product rule? Yeah. Okay, now quotient rule. Okay, so quotient rule is f of x is divided with g of x, right? And if I want to take the derivative with respect to x of this, so this becomes the derivative of f of the first function, that is f of x, times the second like the denominator, or this, I would say that this is first function and this is second function. So the derivative of the first function times the second function as it is, minus the first function times the derivative of the second function over the second function whole squared. So this is what the quotient rule says. These two things are very important, and maybe you're going to see some questions on this, it's sure. Okay, and yeah, we are good to go with this chapter even. And now we are heading towards the next chapter, that is applications of derivative. So y equals f of x, then dy by dx is the slope of tangent y equals f of x on point P. What basically dy by dx says that it's the slope of the tangent at that point, right? So that is what it basically says. If tangent is parallel to x-axis, then dy by dx equals 0, and if tangent is parallel to y-axis, then dx by dy equals 0. I hope you understand that. Okay, next here comes the most important part. If a function is increasing in A and B, if x1 is less than x2 in A comma B, right, in closed interval, right, then f of x1 should be less than or equal to f of x2. Let me tell you right over here. First, let me yes, first increasing, second strictly increasing, third decreasing, and fourth strictly decreasing, right? Okay, now we're going to just have a look at these four cases. If x1 is greater than x2, let's not talk about the stuffs that are being written in this PDF, but let's just focus on mine. If x1 is greater than x2, then for function to be increasing, f of x1 should be greater than or equal to f of x2. Okay, or f dash of x, that the derivative of the function should be greater than or equal to 0. Note it down, because you are going to see a question or maybe couple of questions in your boards or exams surely. And if it's strictly increasing and x1 is greater than x2, then f of x1 is just greater than f of x2. It's not equal to, right? That means that f dash x is greater than 0. Same for this decreasing. If x1 is greater than x2, then f of x1 should be less than or equal to f of x2. That means f dash x should be less than or equal to 0. And if we talk about the strictly decreasing function, if x1 equals x1 is greater than x2, then that says f of x1 is less than of f of x2 that says that f of x f dash x is less than 0. So this is what it is all about. Like, this chapter is just tilted on these four parts, I would say. Okay, and don't think about these stuffs because they are like quite complicated to understand, but what I just explained to you, that is more important. Okay, if a function is monotonic, if it is strictly increasing or strictly decreasing on a and b, like if a function is strictly increasing or strictly decreasing in a given interval, then that is called monotonic function. Okay. Okay, and now if you talk about maxima and minima, take the derivative of your function and just check like their values on which they are going to be 0. So like you can find the maxima and minimum in the maxima and minima, the point of maxima and minima from there. That's it. Now we're heading towards the integrals. Okay, so let's just counter the most basics formulas. Integral of x to the n is x to the n plus 1 over n plus 1. The integral of 1 over x is ln of x plus c, where c is constant of integration. Well, you know what? Let me tell you something. Did you remember that the derivative of log of ex was 1 over x, from like we have studied it in this video itself. So what we did, taking integral both sides, with respect to x, so like this integral and this cancels out. It means that integral of 1 over x dx is just log of ex plus c, log of x to the base e plus c, or ln of x plus c. So and integral is called the antiderivative, like this is called antiderivative. So you can see all the stuffs that are being related with that derivative. So the integral of a to the x dx is a to the x over ln of a plus c. This you can just use this, and you can just like derive it from this very first formula, right? When you take x to the minus 2 as your integrand, and the integral of sine of x is minus cosine of x plus c. Integral of cosine of x is sine of x plus c. Integral of secant square of x is tangent x plus c. Integral of cosecant square is minus cotangent of x plus c. Integral of secant x tangent x equals secant x plus c. Integral of cosecant x times cotangent x dx equals minus cosecant x plus c. Integral of tangent x dx is log secant x plus c, the absolute value of secant x, right? And then rest of the things is, yeah, they're written over there. And I don't think you have time to prove them down, but you have to just memorize them. And well, in this looks very ridiculous, but let me tell you the most important ones. This is the most important, and this is the most important, right? Okay, and I don't think anything most important than that. And if you want, I can prove it down. Let's prove it down for you. I'll tell you how to integrate a function, something like this. Like as I told you in this video, like you have to remember for some basic let me just get over that page firstly. Where it was? I think where did it went? Base. Okay, it was in trigonometry, right? Okay, so here it is. So that's what some useful substitutions. So that's what I told you to memorize it, because I'm going to use them down to prove some integrals. So I'm just going to use this part. So a square plus x square then put x equals a times tangent theta or a times cotangent theta, but I will go with a times tangent theta. So that's what we are going to use. Okay, so here it is. So I'm having the integral of 1 over x square plus a square dx, right? So I'm just going to use substitution. Let's say that x equals a times tangent theta. So the derivative comes out to be a times secant square theta d theta. So this becomes integral dx becomes a times secant square theta d theta over a square tangent square theta plus a square. So a times the integral secant square theta d theta over, take the a square common out, we are having 1 plus tangent square theta. Cancel 1a, so 1 over a times the integral of secant square theta or d theta over 1 plus tangent square theta is secant square theta. I hope you know that. So this being cancelled out, and 1 over a times the integral of d theta, that comes out to be 1 over a times theta. What was theta from here? Calculate. Theta comes out to be arc tangent of x over a. Replace, just put x theta equals arc tangent of x over a, and that's where we are good to go with our proof. This is what it is. So that's how you can just do it with the proper substitution. That's it. Okay, so by parts, again very important. Use Eilert rule. Eilert, or maybe you can just go with this. You just have to check that out. Replace, look, here you are having u and v. These are the function of x, obviously. And let me tell you what you have to take as u and v respectively. So for u, you have to take the derivative of u. It means you have to take a function that is easily differentiated, right? So you just have to check the function whether it is easily differentiated or not. Let me take some examples. Like if you take log of x, so it's not easily integrable, although it's integrable, and the integral of it comes out to be x ln x minus x plus c, but it's easily differentiable because the derivative of log of x to the base e is 1 over x. That's it. So you just have to replace your u with log of ex if given in your function, and the rest of the function will go with v, right? So that's how you have to just check your function. Okay, and now here are some partial fractions. You can just read them down. You just have to use partial fraction method, and just be careful that the degree of the denominator should be higher than the degree of the numerator. Then only you should apply this. Otherwise you're going to waste your time just using partial fractions. Mostly this is going to be used, right? Then like p of x plus px plus q over x minus a times x minus b. Like you have to write it down in this manner, that is a over x minus a plus b over x minus b, and then you have to calculate after comparing a and b, and then you are good to go with your integral, right? Now okay, so for this again, this kind of very important, these kind of things are being appeared in your question in your exam. Then just divide the numerator and the denominator with cosine squared x, and you will see some sort of substitution, like easy substitution methods. Okay, so you can just read the steps, right? Because again they're very important, right? Okay, so yeah, okay, and now I'm just moving slowly because I want you to just take the screenshot of all the stuffs, because maybe you're going to use them. And please just take care about this also. Please just read it down once. I'm not telling you to just revise it or memorize it, but read it down once. Okay, And now heading towards the properties of definite integral. So the integral from a to b of f of x dx is the integral from a to b of f of t dt. So t is just a variable, so or x is also variable. Well, we can say that it's index variable, so it doesn't depend to anything like the value of that integral. Although if we talk about the indefinite integral, so that cannot be equal to the integral of f of t dt. Please be careful about that. There are a lot of misconceptions like from this. And then the integral from a to b of f of x is minus of the integral from b to a of f of x dx. The integral from a to b, the third one, the integral from a to b of f of x dx equals the integral from a to c of f of x dx plus integral from c to b of f of x dx. Right? Because it's easy. I hope you understand that. You just broke that integral into two parts, and c should be in between a and b, obviously. And then only you can just break them down. Or let me just tell you what's this. Let's say that our integral from negative infinity to positive infinity, so that can be written as from negative infinity to 0 and plus the integral from 0 to infinity. So that's how you do that. Okay, next, again this is very important. The integral from a to b of f of x dx is the integral from a to b of f of the sum of the limits a plus b and minus the variable x. Okay, and when you plug b as 0, then you are having this result. So yeah, again this is very important. You have to check your function whether, like, if you're like this is very important. Integral from negative a to a of f of x dx. If your function is odd like this, you have to check this down in your function. Just replace x with negative x and check whether it comes out with the negative of f of x or positive of f of x. If it comes out with negative of f of x, then your function is odd and the integral comes out to be 0. And if it comes out the positive f of x, then 2 times that integral from 0 to a. Right? Okay. A limit as a sum. I don't think that CBSE would ask some question on this, but although just remember this formula, that's it. And this one, this is infinite geometric series. Okay. And now applications of integrals. Well, you would be given some y equals f of x, and you just have to integrate with the given limits, right? That's it. That's it. Now we're heading towards our next chapter, that is differential equations. This is the last chapter of calculus. Okay, so order of differential equation is the order of the highest order derivative appearing in the equation, right? Just be mindful of that. And the degree of this of differential equation is the degree of the highest order derivative, like the highest order derivative, the degree of the highest order derivative. And order was the highest order derivative. I hope you understand that. Okay. And well, what's homogeneous differential equations? Dy by dx in this form are both homogeneous of same degree. Okay, let me explain it to you after highlighting it. So dy by dx is equals f of x comma y over g of x comma y, where f of x comma y and g of x comma y are both homogeneous functions in the same degree in x and y. That is an equation of the form dy by dx of f of y over x. That's it. To solve, here you have to solve, put y equals nu x, or you can put y equals lambda x, whatever you want, and then take the derivative with respect to x of that function. Okay, linear differential equation. So equation of the form, this is the form of linear differential equation where both p and q are functions of x only. And to solve it, this is your integrating factor. Sometimes CBSE asks this in like 1 marker questions. So the integrating factor is the e to the times the integral of p dx. That's it. So this is what to solve our differential equation. IF is the integrating factor and q is this constant or this function of x, right? And let me tell you a very interesting part here. Well, if you look closely here, this is dy over dx plus p of y, p times y equals q. And if it comes dx over dy, then p times x equals q, where p and q should be the function of y respectively. Vice versa. That's it. That's what I just want to tell you, that please keep remember, because again sometimes it plays with us. Okay, so now we're done with our the very last chapter of calculus, and we are heading towards vectors. A quite good weighted chapter in CBSE. So position vector of this point is given by OP, that is this is the, and its magnitude is square root of x square plus y square plus z square. Okay, and just remember that if a vector equals a1 I cap plus a2 j cap plus a3 k cap, then a1, a2 and a3 are the direction ratios of a vector. Direction ratio is very important. It is like a1, a2 and a3. You can understand this as the coefficients of the respective unit vectors, right? Triangle law of addition. AB vector plus BC vectors equals AC vector. Okay. If R equals AI cap plus BJ cap plus CK cap, then A, B, C are proportional to its direction ratios, and its direction cosines are L, M, N given by. Okay. So basically, I hope you understand that A, B, and C are the like direction ratios of respectively unit vectors, right? Of their respective unit vectors, and it is directly proportional to the direction cosines. And direction cosines is, let's denote it with dr. So it's a comma b comma c over, this is the unit that, or let's say that direction ratio over the magnitude of that unit vector, of that right, of that position vector actually. That's it. So if we talk about L, so it's a over plus minus obviously square root of like the magnitude of position vector. And if we talk about M, B, and N would be C, right? And if you look closely, then L square plus M square plus N square equals 1. Again, very important, please remember that. Now two vectors A and B are collinear if and only if there exists a non-zero scalar lambda such that B vector equals lambda times A vector. Just keep remember that. That's very important. Okay, if A vector equals a1 I cap plus a2 j cap plus a3 k cap, and B vector is b1 I cap plus b2 j cap plus b3 k cap, then the two vectors are collinear if and only if a1 over b1 equals a2 over b2 equals a3 over b3. That's it. Just divide the respective coefficients of unit vectors with each other and equate it with each other actually. And now this is the direction of a vector that represents with a cap, that says a cap equals the vector a vector over the magnitude of that vector. Okay, and if P and Q are the 2 points, then the vector joining P and Q is given by, just subtract their respective direction ratios with each other, like with them, like x2 minus x1, y2 minus y1, and z2 minus z1, and then multiplied with their respective unit vectors, that is I cap, j cap, and k cap. Right. Section formula, again very important. Internally it is given by m times the b vector plus n times a vector over m plus n, and externally it is given by m times b vector minus n times a vector over m minus n. And now scalar or dot product, a vector dot b vector is the magnitude of a vector times the magnitude of b vectors times cosine of theta. Theta represents the angle between these two vectors. Okay. And if a equals a1, if a vector equals a1 I cap plus a2 j cap plus a3 k cap, and b vector equals b1 I cap plus b2 j cap plus b3 k cap, then a vector dot b vector is a1 b1 plus a2 b2 plus a3 b3. It's again very important. And e vector times dot a vectors, is the magnitude of a vector whole squared. Now projection, very important. Projection of vector a on b is a vectors dot b vector over the b vector, the magnitude of b vector, and with the projection of vector b on a, it's a vector dot b vector over the magnitude of a vector. Well, we are taking out the projection of a vector on, let's say that x, then the dot product of them with respect to the, like, the magnitude of this vector on, taking on, okay, again with this, so you can just relate it with that. And this is very important. If a vector is perpendicular to b vector, then a vector dot b vector is always 0. And how so? Because cosine of theta is 90, theta is 90 degree, right? In between these two vectors, theta is 90 degree, so cosine of 90 degree is always 0. That is why a dot b vector is 0. And now mutually perpendicular unit vectors, I dot I equals j dot j equals k dot k equals 1, right? Keep remember that. And I dot j equals j dot k equals k dot I, that too equals finally 0. Okay, the vector or cross product, so it's just this: a vector cross b vector equals the magnitude of a vector times the magnitude of b vector times sine theta and n cap perpendicular to the plane containing a and b. Or maybe you can remember this formula because this is widely used. The determinant of a vector and b vector to find a cross b with this: if a is parallel to b, then a cross b is 0 again. If it is parallel, then theta is 0 degree, and sine of 0 degree is always 0. That is why a cross b is 0 here. And for mutually perpendicular, I cross I equals j cross j equals k cross k, that is 0, right? Because they are okay. And then if we take the cross of I cross j cross k I, and finally k cross I j. Okay, now area of triangle, if a and b represents the adjacent sides of a triangle, then its area is given by that. Well, a and b are the adjacents, like sides of a triangle, then the area is 1 over 2 times the determinant of a cross b, or the magnitude of a cross b, and a cross b can be evaluated from here, right? Okay, although we have studied about the evaluation of the like a triangle with all three sides in determinant chapter, that was del equals 1/2 of the determinant of x1, x2, x3, y1, y2, y3, and 1 1 1. But it's all right, there are two ways of evaluating this. Okay, and now we are good to go with the next chapter because we are done with this chapter. Okay, and now heading towards 3D, that is three-dimensional geometry. Okay, this is quite good chapter, I think. Okay, so Cartesian form, this is a form of representing Cartesian equation of a line is parallel to the line. Okay, this is what it is being represented with, and vector form is something like this. Okay, so just keep remember that vector form and Cartesian form, right? Angle between two lines is given by a1 a2 plus b1 b2 plus c1 c2 over the magnitude of the first vector times the magnitude of the second vector. You can easily understand this while using this formula: cosine of theta equals a vector dot b vector over the magnitude of a vector times the magnitude of b vector. So just opened it up, and that's why it is looking quite ridiculous. Okay, so angle between two lines with direction cosines. Okay, like with direction cosines, we are out to find the angle between two direction cosines. And what were direction cosines, as we have studied here? Let me tell you again. So these were the direction cosines. So angle between two direction cosines, that is L1 M1 and N1 with L2 and M2 and N2. So that's how we're gonna find that. So here it is. This is the formula: cos theta equals L1 L2 plus M2 M1 M2 plus N1 N2. That's how. Okay, and now shortest distance. Okay, this is very important. Vector form: R is representing this, and again R is representing this vector. So the shortest between them is this. This is what the magnitude of b1 vector cross b2 vector, like this one, these two things, times like dot a2 vector minus a1 vector, a2 minus a1. You will be given these two things and these two things, and you have to compare them. Okay, so yeah, so just keep remember that the one that is being multiplied with lambda is your b, like b term, b vector, and the one which is independent of lambda is a vectors, and that's how you can just do that. So you don't need to care about that whether a1 we have to take a1 minus a2 or a2 minus a1, because eventually we are going to have a determinant or the magnitude, the absolute value, so we don't care about a negative sign inside that all. And times, like the major part is to calculate b1 cross b2. That's it. So this is what we have to do. And how we're gonna do that, as I told you here in the previous chapter, that was here. So b1 cross b2 is the determinant of I cap, j cap, k cap times of b1 b2 b3 and so yeah, you can just do that, b1 vector and b2 vector respectively, because their terms are not just given over here. Or you can say that like you would be given b vector and b1 vector and b2 vector. That's how you can just put their values in here, and that's how you can calculate this. So that's what I want to tell you, that right. So that's how. And then take the derivative, take the absolute value of them, and that's how you're good to go with the shortest distance. Okay, so this is the form. Like if we look closely, This is another form, but this looks very ridiculous, and that's why I would say that go with this only. Okay. And I think so far it's good. This contains a lot of unnecessary stuffs, but still maybe they are useful. But I haven't seen that much amount of question being asked from all these stuffs. Okay, but yeah, you can just check. You can just read them out if you want. Right. Actually, I'm having some trouble with my like vocal, so please just bear with me. Okay, so now we are heading towards the next chapter, that is linear programming. So basically in this chapter it's very easy. You just have to solve given some kind of like some kind of inequalities, and you just have to plot them on xy, given xy plane, and then you just have to look for the feasible reason in which all the inequalities combine each other to form that feasible reason. So you just have to check them. If you find that successfully, then just take the corners of that feasible reason, like the coordinates of the corners of that feasible reason, and then you just have to check for x comma y. Like, basically what I'm saying, that let's say that okay, this is okay, this is what xy plane, right? Let's talk about this one, and this one, and well, you would see you have to take this, whether you have to take this downward like this, or you have to take this upward, right? So let's talk about only these two things. So, or let me just uh, maybe I should do with this. Okay, so let's say that this is um, x1 y1, this is x2 y2, and this is x3 y3. So I'm saying that this is your feasible reason, right? All the inequalities, like both the inequalities says that this is your feasible reason. So you just have to draw like this rectangular part, and you would have given a function that you have to check for maxima and minima values. Let's say that z equals ax plus by. So you just have to write over here ax plus by and x comma y. So firstly x1 y1, x2 y2, x3 y3, and just replace x with respective and y with respectively in these terms, and you're gonna have some values, and you just have to check whether on which coordinate this is maximum and which coordinate this is minimum. That's what you have to tell. So this is what this chapter is all about, and rather than that, this is nothing, right? Okay, and now heading towards our last chapter, finally, in just 1 hour and 13 minutes, we are on our last chapter, and that is probability. So probability is okay, yeah. So P of A is number of favorable outcomes over number of possible outcomes, right? The most basic formula of probability. And P of A bar is 1 minus of P of A. And what is A bar is, P of A bar is representing that even, like the probability of not happening that event, right? So P of A union B is P of A plus P of B minus P of A intersection B. That's necessary to be like remembered. If A and B are mutually exclusive events, then P of A intersection B is 0. 1 mark question may be asked from this. If P of A bar intersection B equals P of B minus P of A intersection B, These things are going to are going to be used in questions, so these things are important. And if we talk about the play like cards, so you can just read them out. Again, quite important. So yeah, you can just read them out if you want. Conditional probability, this is represented with p of a and like this thing, right? So that says that probability of occurrence of a when b has already occurred. Basically, whatever would be occurred would be written on the this side, right? So this says that p of a intersection b over the probability of occurred part. So that is what it's all about, right? Okay. And the conditional probability of p of a bar over b, well, it's also being represented with p of a over b. It does also mean that p of a intersection b over p of b. B has already occurred, right? Okay. So yeah. And now multiplication theorem on probability, that says that p of a intersection b is equals p of a times p of b over the conditional probability of p of b over a equals p of b times the conditional probability of p of a over p of b. Well, it's quite important. Maybe maybe three would be given in question, and one would ask, like, let's say that these two things and this one is given, and you ask this going to be evaluated. So with the help of multiplication theorem of on probability, you can evaluate that also. Okay, so if you asked, or if you see that your two events are independent events, then p of a intersection b can be written as p of a intersection p of b, right? Okay. And now yeah, this is also very important. p of a p of a intersection b equals p of a intersection p of b, same as of independent events, right? Again, very important. And this one is also okay. Now we're having a look of Bayes theorem, that says, like, you just have to remember this formula, right? That's it. And this is a way of representing a quote conditional probability in different ways. Like, I hope you understand that p of even over a can be represented as p of even times p of even times p of a over even over the probability and this probability, right? And same for this one is also something like that. And the rest of the things is again unnecessary, but if you want, you can just read them out. And that's how we did this. So we are done with our the mathematics class 12. So yeah, it was quite good, and I hope that you understood all the stuffs like perfectly. And if you have any kind of doubt, please just comment it down, because I'm ready to just reply your doubt, right? And yep, so we are done with this. And thank you for watching this video till now. But if you have watched this till now, you must have understood a lot of parts of class 12 mathematics, but still you have to practice some questions to make it more clear. So thank you so much, guys, and stay tuned for higher mathematics, because as you can just watch my other videos on my YouTube channel, you can have a look of a lot of different and higher mathematical questions. So you can just check them out if you want, and stay tuned for next. And well, let me tell you, I'm just going to upload the evaluation of zeta of 2, like this one, Riemann zeta of 2. Like, I'm just going to prove it. 1 over n squared, that is pi squared over 6. This is very famous Basel problem. So I have proved, I'm just going to prove it down with using Fourier series, right? I hope you know what Fourier series is. It is f of x equals a naught over 2 plus the infinite sum as n goes from 1 to infinity of a sub n cosine of nx plus the series as n goes from 1 to infinity of b sub n sine of nx, where a naught is 1 over pi times the integral from negative L to L, where L are the like closed interval limits of x. Mostly it is pi, right, of f of x dx. A sub n is 1 over pi integral from negative L to L of f of x times cosine of nx dx. And finally b sub n is 1 over pi integral from negative L to L of f of x sine of nx dx. And if you guys are in class 12, please ignore it. And thank you so much guys. Plus and just wait for the moment when I upload the evaluation of zeta of 2. Thank you so much for watching this video. Stay tuned for the next video.